Right, people. Today, now this video, we are doing the worksheet number 2. I have done the worksheet number 1 in the previous one. You can check it in the resources channel. It's available. So now let's discuss this one. You can see first question. First question. I'll take a red color. Right. In the second period of the periodic table, identify the element that has no p electrons but has stable s configuration. What do you mean by stable s configuration? Second period, you have lithium and then you have beryllium, right? So this is 1s1 and this one is 1s2. So stable s configuration means fully filled orbital, right? A fully filled orbital is considered to be stable. No p electrons, so okay, no p electrons and stable s configuration. So it definitely should be beryllium, right? It definitely should be beryllium. Then next question. Identify the subshells along with the azimuthal quantum number L. Okay, azimuthal quantum number L and magnetic quantum number M sub L with principal quantum number n equal 3. N equal 3, what are the possible L values now? L equal 3, what are the possible L values? What are the possible L values for n equal 3? You know, L equal to like n minus 1 is n is less than and equal to n minus 1 is like n is less than and equal to n minus 1. That means L can be like 0, 1, 2. We did this in class. So this one is going to be s orbital, right? This one is going to be s orbital, this one p orbital, and this one d orbital. So subshell, you have s, you have p, you have d. Then the azimuthal quantum number 0, 1, 2. Yeah. 0, 1, 2. Then magnetic quantum numbers possible for these values. Now magnetic quantum numbers possible for 0 is only 0, you know that. It is like minus L plus L. M sub L is equal to minus L to plus L, right? So it's going to be minus 1 here and 0 and plus 1. We did this in class. Then d orbital here, then minus 2, minus 1, 0, plus 1, plus 2. Those are the possible values. Then maximum number of electrons. You know, 2n squared. That is for energy level. No? This is for a certain energy level. Now they are asking for each subshell that how much electrons can we put, maximum number of electrons. You know, s orbital can be filled only with 2 electrons. That's a very basic thing. Then p orbital you can fill up with 6 electrons. Then d orbital you can fill up with 10 electrons, right? Maximum number of electrons in each subshell, right? So that's one done. Then we have true or false statements. Now this one is very important, right? Let's see. Sulfur has the highest electron gain energy. You know that is wrong. Why? Highest electron gain energy was chlorine. That zigzag variation, you had chlorine first, then you had fluorine, then only you had sulfur, right? Sodium, magnesium, magnesium, and phosphorus, sulfur, chlorine, right? Sulfur is here. Like that only it went. So chlorine is the highest negative, right? You have to remember highest negative, right? Highest negative. So when they say like highest, you have to take it like highest negative. Highest electron gain energy means highest negative. So this statement is wrong. Fluorine has the higher electron gain energy than chlorine, and You know, like chlorine is like greater than fluorine, so it is wrong. Then electron affinity of chlorine is negative. Electron gain is negative. Electron gain is negative. If electron gain is negative, then electron affinity is going to be positive. So this statement is also wrong, right? Electron affinity of chlorine is going to be positive. Why? Electron affinity is the equal and opposite of the electron gain. So it is the opposite. The second ionization energy of magnesium is greater than sodium. So what is that? If we draw the ionization energy variation, you know it goes like this, like up, one, down, then again up, down, up, right? Right, then it's going to be sodium here. This is the first ionization energy. This is magnesium. Ne? So magnesium's first ionization energy is greater than sodium. But when you go to second ionization energy, magnesium jumps to here and sodium goes there, right? You know, in the next previous period, we have a drop in. This is like very larger. It goes to the previous table. So this statement is also wrong. Then, so here wrong. Fifth statement. Oh. So when I do that, it's going to change. Okay, whatever. Hundred rule states that two electrons cannot have same set of four quantum numbers. Is it the Hundred rule? No. Then that is Polish exclusion principle. So this one is also wrong. Atomic radii of Cl minus is larger than sulfur. That one you learn, right? So when you add an electron to chlorine, now if you write sodium, magnesium, aluminium, silicon, phosphorus, sulfur, chlorine, right? So when you add an electron to the Cl minus, it will increase its radius and come somewhere here, right? So somewhere around here, you don't have to know the exact value. It comes somewhere here. So it's going to be larger than this one, this one, this one, this one, right? So this statement is correct, finally, right? The next one, electron gain energy becomes positive down the group. Less positive down the group. You know, electron gain energy is going to be more, what do you call, more negative across the period. What? More negative. More negative across the period. Down the group, it's going to be less negative. Less negative. How do you remember this? Chlorine is the highest. Chlorine was the highest. So remember, like when you go to the right of the periodic table, electron gain energy increase. I mean, the negative value of electron gain energy increase. When you go down the group, the electron adding becomes harder, right? Because like the electron cloud is going to be bigger and bigger. So what happens is electron gain becomes, because the electron gain becomes harder, so less exothermic. Less negative means more positive. Less negative means more positive. Less negative means more positive. More negative means less positive. Less positive. Electron gain energy becomes less positive down the group. Wrong, right? More positive down the group. That is how you break down the question, right? That is how you break down the question. Okay. I have to go below now. I have to clear everything. Now we are in the 8th question. Right, we are in the 8th question. Okay. When n equal to, the maximum number of orbitals possible is 8. N equal to maximum number of orbitals. I told you the equation is going to be n squared. Number of orbitals, that equation is n squared. So 2 squared is 4. Right? So this is 4. In an atomic spectrum,